Okay, guys, so yesterday we had to prove triangles congruent by showing that all of the parts are the same. For the next couple of days, we're going to talk about some shortcuts. So we are going to prove triangles congruent just by proving that their three sides are congruent. That's going to be enough information to tell us that those two triangles do match up. They are congruent. So again, we're talking about order mattering. When we're looking at this congruence postulate of side AB matches up with side RS. Put the bar over it. Side BC with the two tick marks matches up with side ST. And side CA matches up with TR. So notice that I'm going the same order, same direction when those triangles are turned in the same orientation. So then, if we know those three things, that's enough information to say that triangle ABC is congruent to triangle RST. Same order. Okay, so can you prove that these two triangles are congruent by the side congruence postulate? If you can, write a congruent statement. So looking at this first picture, I noticed that these two both have 9s, so I'm going to put a single tick there. And then I noticed that these two both have 8s, so I'm putting a double tick there. Those match. They're the same length, so they're congruent to each other. Then I see a line LK. Think back to our reflexive property. It tells us that it's going to be congruent to itself. So LK is congruent to LK, which means that matches up. I have 3 sides marked. So I can say yes, and I'm going to go ahead and say by side because we're going to get some more shortcuts later on. Right now that's the only one we have. But then I can say triangle JKL is congruent to triangle. Now here's where I have to be careful. So J to K is 8 long. I want to go in the same direction. So I'm going J, which is on the outside, to K, which is touching that middle piece. So I go over to this other triangle. I need to say M to K. So M, then K, and then I went JKL. So KL, I'm going up in the same direction. So MKL would be how I list that triangle. That's our congruent statement. All right, if I look at example B, I have double ticks and I have triple ticks, but I don't know anything about that side RS compared to side TB. It looks like they probably are congruent. They could be congruent, but we can't assume. So since we don't have the markings there, we're going to just say no, those are not congruent. All right, so let's check out this graphing. We have triangle DFG and triangle LMN. And I'm going to go ahead and plot those points while you plot those points on your own notes. So -2 means left 2, and then I go up 4 for point D. And then I'm going to go right 4 and up 4 for point F. And then point G is -2, +2. I'm going to go ahead, hopefully you have a straight edge that you're using. I'm sketching this in to save time. And then L is at -3, -3. M is at -3, +3. And N is at -1, -3. So again, sketching in those line segments to make my triangle. Just graph the triangles in the same coordinate plane. Done. Show they are congruent. Well, our only method for showing they are congruent is to find the lengths, because we need to know that all 3 sides are congruent. So in this case, we could do distance formula a total of 6 times. Let's save ourselves some time here. So we know that side DG, since it's vertical, I can just count it, is a length of 2. We also know that side LN, since it's horizontal, I can count it, is 2. There's a pair of matching sides. Then I know that DF, if I count it, is 1, 2, 3, 4, 5, 6. And I know that LM, if I count, is 1, 2, 3, 4, 5, 6 boxes as well. There's 2 of the 3 sides. So from here, we just have to do distance formula twice. So I'm going to do FG. Big square root. My x values for F are 4, and for G are -2. So 4 minus a -2, I'm going to square it. And then for the y values, I have 4 minus 2 and square it. So 4 minus a -2 is 6, and 4 minus 2 is 2. So then I have 6 squared is 36, and 2 squared is 4. So I get the square root of 40. And yeah, we can reduce that, but again, we're just checking to see if these are the same. So then I'm going to look at, since I did FG, M, N. So point M is at -3 minus a -1 is our N. Square that. And then our y values are 3 minus a -3 and square that. So -3 minus a -1 is like -3 plus 1. So I get -2 squared. And then 3 minus a -3 is 6 squared. So -2 squared is 4. 6 squared is 36. So I get the square root of 40. And look at that. They match. So it says show they are congruent. So then we can say, by our congruent statement, triangle DFG is congruent. And I want to go in the same order. So DF was my long side of 6. So I'm going to say triangle LMN is congruent, and I'll say by side, side, side. All right. We have a proof coming up. It's been a while since we've done a proof. So first off, we have a picture there, and it says FJ is congruent to HJ. That was a bell for class. FJ is congruent to HJ, and G is the midpoint of FH. So let's start off by putting those given statements where they go. So FJ is congruent to HJ, and G is the midpoint of FH. Our reason there is that it's given statements. And I'm going to make sure that's marked in the picture, and I see that FJ and HJ are marked in the picture. I'm also going to put my prove statement down here at the bottom. So triangle FGJ is congruent to triangle HGJ. So that's what we're trying to get to. Our only method so far, besides showing everything is congruent, is side, side, side. So we know we should be focused on the sides and trying to get them to be matching pieces. So I notice my reason for number 2 is definition of midpoint. And so my given statement says G is the midpoint of FH. So we need to think, what does it mean to be a midpoint? Well, it means that then the two segments are congruent to each other. They're equal to each other. So if G is the midpoint of FH, then I know that these two pieces have to be congruent. So I want to make sure I'm going in the same order. So I'm going to go outside to inside here so that I have FG is congruent to HG. Those two pieces match up. They're the same length. Okay? Then I notice I only have one more side that's not marked, and that side matches up to itself. So I can go ahead and say that it is congruent to itself. So JG is congruent to JG, and I have to put the bar over both of them. My reason there, something being congruent to itself, is reflexive. Property of, and I have to look back and see that I am using a congruent symbol, so property of congruence. Now, I look at the picture, I see 3 sides marked, so my reason that the triangles are congruent is by side, side, side. All right, we will practice more of these in class. As always, if you have questions, please come in and see me. Have a great day.